As you can see, we have set up the instrument in 1 to 2 GHz range. In transmitter, you can see the RF output is coming from up converter and 20 dB is connected at output. And similarly, at receiver end, the output is coming from down converter input and a 20 dB connector is connected at the input. Now, as you can see, at the transmitting end, we have connected a log periodic antenna. We can connect a dipole antenna for measuring at 1500 MHz, but log periodic is quite broadband. It goes from 1 to 2 GHz range. And at the other end, we have connected a dipole antenna. The plane of polarization here is horizontal, but using the cube, we can connect the patch antenna, the dipole antenna vertically also. So at this time, with the transmitting antenna horizontal and the receiving antenna vertical, we can measure the cross polarization discrimination, and we can do the co-polarized measurement as well. This is the case for a dipole antenna. We can connect another log periodic antenna. These are all microstrip antennas, or a Yagi antenna. Now the dipole and Yagi, they work in the range of 1500 to 1600 MHz range. Now this is the batwing antenna. Now as you can see, it is nothing but an array of dipoles. So if we keep it in this way, the antenna is vertically polarized. So as the log periodic horizontally polarized, so we have to keep the batwing antenna in this fashion to do the azimuth measurement or the E-plane measurement of batwing. Similarly, we have a spiral antenna. Now, this antenna is basically circularly polarized. So, with a linear antenna, it will give 3 dB less gain because of the axial ratio, but it has its own inherent gain and circular polarization. Similarly, we have another microstrip antenna, which is a GPS patch working at around 1575 MHz. Now, as you can see, the polarization of patch antenna can be found by rotating it in 90 degree, and wherever we get the maximum polarization is the polarization of the patch. Similarly, we have a patch which is transformer fed. This again works in 1500 to 1600 MHz range. Similarly, we have another patch which is an insect fed patch. Again, the polarization can be found by rotating the antenna at 90 degree. Now we have an array of patch. This is a 2 by 2 array of patch, and it is linearly polarized. Same polarization can be found, and again it works in the range of 1.5 GHz. Similarly, we have a circular polarized patch array of 2 by 2. Now this will have circular polarization, so rotating the patch by 90 degree will not cause any change in the reading. Now this is the dish antenna. Now as you can see, it has a feed, a parabolic feed, which is the end fed feed. This is the dipole and this is the balloon, and the feed is at the center of the parabolic reflector. It can be connected like this. This is how we can connect the feed and can mount the parabolic dish with the screw provided. Dish will normally work in the range of 1.7 to 2 GHz. Similarly, we have a conical horn antenna. This is like a circular waveguide, and as you can see, this is the lambda by 4. So again, it works in the range of 1.8 to 2 GHz. All the antennas have screw provided with them so that they can be mounted on the